be given that point A at 3 minus 2 and point B at B1, so there's an unknown there, are root 13 units apart. So it's telling us the distance between the 2 points, and it's given us 2 sets of coordinates. So that really is telling you you need to use the distance formula, which is not in your formula sheet. You need to learn it. I'm going to write it down here. So for any 2 points, the distance between them, d, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And when I say x2 and x1, I mean the x coordinate of the whatever you call the second point, and the x coordinate of whatever you call the first point. For y2 and y1, I mean the y coordinate of whatever you call the second point, and the y coordinate of whatever you call the first point. So in this case, I'm going to call the 3x, so I'm going to call point A point 1. So I'm going to call this x1 and this y1, and I'm going to call little b x2 and this y2. Now actually, when you get better, if you practice this quite a lot more, you'll realise that it's very convenient. So whatever you have the unknown in, it's often easier to call that the second point. It won't necessarily, it doesn't mean you're not going to get there if you don't. It just means it might be a bit quicker, maybe one less line of working, but it really doesn't matter that much. So I'm just going to write down what I know. So firstly, I know what the distance is, so it's root 13. So root 13, which is the distance between the two, so we've been told it, equals the square root of x2 minus x1, so that's b minus 3 squared, plus 1 minus minus 2, 1 minus minus 2 squared, just like that. So then what we can say is, well, I would consider squaring both sides. Square both sides. Now, if you've got one thing square rooted equals something else square rooted, squaring both sides is quite a good idea. Square both sides. So that would say 13 equals b minus 3 squared plus, well, this is 1 minus minus 2, so that's 1 plus 2, which is 3 squared. Just like that. So now we can expand this b minus 3. So 13 equals b minus 3 squared means b minus 3 plus, well, 3 squared is 9. So now 13 equals, if I expand this, that's going to say b squared minus 3b minus another 3b plus 9. That's the brackets, and then there's plus another 9. So now this would say, just go here, 13 equals b squared minus 6b plus 18. Now, we haven't done a great deal on quadratic equations, but I'm just going to show you how to do it, and hopefully it won't be too bad. So whenever you get something like this, you need to make it equal 0. So I'm going to move this 13, I'm going to subtract 13 from both sides, leaving a 0 here. So 0 equals b squared minus 6b plus, well, it's 18 minus 13, which is 5, plus 5. And all I've done take away 13, take away 13. Now what we're going to do is try to factorize this quadratic, which we have done. So if we can factorize this thing, it will help us a lot. So you're looking to factorize b squared minus 6b plus 5. So what that means is, there's nothing in front of the b squared. Well, there's a 1 that you can't see, so that's fine. We're looking for two numbers. Their product is 5 and their sum is minus 6. So if you think of 5, it's a prime number anyway. You've got to have really a 5 and a 1. And they've got to have the same sign in order to multiply to make a positive. So they could be minus 5 times minus 1 or plus 5 times plus 1. And then their sum needs to be -6. So these two add up to -6. These two add up to +6. So that's not what we want, but that is. So the answers, or the factors that go in here, are -5 and -1. So now we have b minus 5, b minus 1 equals 0. So that means now you've got two things being multiplied together to equal 0. Now if I say to you, give me two numbers that multiply to make 0, you might say, well, 3 times 0 is 0, or 5 times 0, or -8 times 0. The point being, you can't have two numbers multiplying to make 0 if one of them isn't 0. It's not possible. So that means one of these factors has to be 0. So we consider the cases where either could be 0. So either b minus 5 equals 0, or b minus 1 equals 0. And now we just solve those equations. Well, if b minus 5 was 0, just solve for b. You're just going to add 5 to both sides. Or you could just say, well, from what do I take away 5 to make 0? So b would have to be equal to 5. Or in the other case, well, 1 minus 1 is 0, so b would be 1. This will be taught formally much later on, but it is called the null factor law. So whenever you get a quadratic equation with something squared plus something else plus number, or it doesn't have to have the number, but a lot of the time it does. When you get something like that, you can factorize, make it equal 0, factorize, and then you're considering the cases where either factor equals 0, and you just solve for that case.